Hey everyone, it's Mr. Kabbalah. This is going to be an Algebra 1 lesson from eMath instruction on unit number 9, lesson number 2 on irrational numbers. Enjoy! Instruction, unit 9, lesson 2 on irrational numbers. So number 1 has 8 questions to it. It says for each of the following rational numbers, use your calculator to write out either the terminating decimal, which means it stops, or the repeating decimal. So 3 over 4. Okay, well, 0.75. I think 4/9 turns out to be 0.4 repeating, but let me double check that. Yep, 0.4 repeating. Now for repeaters, you can do a bar like that. 0.4 with a bar above it shows that it's repeating. Doesn't matter how many 4s you write down. You could put 0.44 repeating, but I'm just going to use the 1. 5/8, 5 divided by 8 is 0.625. 5/6, let me see if I can open up real quick. Maybe I could just do it right here. Oh. Never mind. So what I'm doing on my calculator is simply top divided by bottom. 0.83 repeating. So be careful with this one because the 3 is the part that repeats. The 8 doesn't. So 8, 3, and just the bar over the 8. If you did it, so here, let me do a real quick. 0.8 with a bar above the 3 is 0.8333, and so on. Whereas if you do 0.83 with a bar over the 8 and the 3, that's technically 0.838383, and so on. So you got to be careful where you put that repeating bar sign. So here we have the square root of 25 over 4. So let's take the square root first. That's 5 over 2. That's 2.5. The square root of 1 is 1. The square root of 100 is 10, so it's 1/10, so 0.1. The square root of 4 is 2. The square root of 9 is 3. 2 over 3 is 0.6 repeating. And then the square root of 2 and the square root of 32, those aren't easy ones to do, so I'm just going to type all of that into my calculator. Square root of 2 divided by 32. Oh, 0.25. Look at that. Okay, moving on. Eventually. Maybe. At some point. There we go. One of the most famous irrational numbers is the number pi. It's a Greek letter. It looks like this, which is essential in calculating the circumference and area of a circle. Use your calculator to write out all of the decimals your calculator gives you for pi. Notice no repeating pattern. Now, I happen to know 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3, 2, 3, 8, 4, 6, 2, 6, and so on. Your calculator, I think, rounds it to this. Actually, I think it rounds it to this. So your calculator, I think, would only give you 1, 4, 1, 5, 9, 2, 6, 5. It would actually make it 5, 4. Again, the calculator can only go to here, so it rounds it. 22/7 is very often used to estimate pi. I tend not to do that, but you can kind of see on your calculator. There it is. It's close. NASA only uses 8 decimals after the decimal point in their calculations, so us using 2 or 3 is probably good enough. All right, for each of the following irrational numbers, do two things. Number one, write the square root in simplest radical form, and then two, use your calculator to write out a decimal representation. So from the last lesson, you might remember that we're going to do factor trees. Factor trees come from 6th grade math. All right, so 32 is 2 times 2 times 2 times 2 times 2. I have two pairs of 2's, so I can bring out a 2 and another 2, and then inside, underneath the radical, this lone 2 here. So this turns out to be 4 radical 2. And then write out the decimal representation. So square root of 32 on my calculator is 5.6568. Now, I'm sure there are rules to how many you need to write on the regions, but for now I'm going to just do 656. Actually, I'm going to round that to a 7. All right, the next one I'll do in a different color, 98. So 7 radical 2. I know I'm skipping a few steps. 9.899. All right, 75. Let's do 25 times 3. That's 5 times 5. So a pair of 5s and then a radical 3. I'm going to skip the whole decimal thing just because that's a calculator thing. I think we can do that on our own. So let's check it on a calculator. What I'll do is the simplest radical form. So 500 is 5 times 100. 100 is 10 times 10. And I think I mentioned in the last video, these aren't the only ones, the only factor trees you could do. You could do 50 times 10 and still end up with the right prime factorization. So 10 radical 5. Let's do 80 here. We got 8 times 10. 8 is 2 times 2 times 2. Again, I know I kind of skipped a few steps. I have 2 sets of 2's. So that's going to give me 4 radical 5. And then finally 117. I can do 3 times. I'm going to do 117 divided by 3 to get my other number here, which is 39. 3 times 13. So I've got a pair of 3's and then the square root of 13. And again, go to your calculator. You can type those in and get the decimal approximations. Then on to number 4. Types of numbers mix and match in various ways. The last exercise shows us a trend that we explored during the lesson. Fill in the statement below based on the last exercise with one of the words in the blank. The product, so multiplication of a non-zero, so not a zero, rational number and an irrational number results in this would be irrational number. Okay, so if you multiply rational times irrational, you get an irrational. But now we're going to explore, what if we have 2 irrationals? So irrational times irrational, what do we get? So it's always sometimes rational or always rational. So that's what we're looking to do. So square root of 5 times the square root of 3. So here we go. Square root of 5 times square root of 3. Square root of 5 times, you know what? I got to make sure I come out of the radical. Let me start again. Square root of 5, move it over, times square root of 3, and I get irrational. All right, square root of 8 times the square root of 18. Rational. Square root of 7 times square root of 11. irrational. And then square root of 11 times square root of 11. That's rational. So let's look at this statement. Based on 5, classify the following statement as true or false. The product, so multiplication of two irrational numbers, is always irrational. Well, we had some that were rational and some that weren't. So this is false. It's not always irrational. It's sometimes irrational. All right. Using what you learned about in middle school, add each of the following pairs of rational numbers by first finding a common denominator, then combine. You know what? Let's do this on a calculator too. So 1/2 plus 2/3, 1/2 plus. So if you don't remember, when you do math, move this over to fraction. 1/2 out of the denominator. 2/3. We get 7/6, which if we want to change that to a decimal, I'm going to hit math, choice 2, and I get 1.16 repeating. Now, some of us might look at that 7 at the end here and say, well, it ends with a 7. But remember, the calculator has to round. So it's actually 1.16 repeating. Okay, if you think of this as the computer screen, 1.1666666. Come on. 6. There's a 6 here, but the calculator can only go here, so it rounds that to a 7. So it doesn't end with a 7. You don't put a 7 here. Okay, we just put 1.16 repeating, and then that's it. All right, 3/4 plus a half. If you do that on your calculator, that would be 5/4, which would be 1.25. 3/8 plus 5/12. That I have to do on the calculator. Or I could do it by hand, but plus. All right, there's the fraction, 19/24. If I hit math 2, I can change that to a decimal. 0.7916 repeating. Again, you might see the 7 at the end there. You would have to know. The calculator won't tell you that it's a repeater because it rounds. So this would be 0.791. Now those parts don't repeat, but the 6 does. So the bar only above the 6. All right. Hopefully that's a little bit of help. Hopefully we'll see you soon.